Okay, I want you guys to write this down. Okay, so what I have written up here is part of a chemical reaction. Which part? The reactants, right, the front. Well, let's use reactants as a proper term, but you're right, it is the front. Okay, so we got magnesium reacting with iodine. So this is an element and that's an element. What kind of reaction is occurring? It's a synthesis reaction. Okay, what happens in a synthesis reaction? They combine. All right, so this is leading to where we're going to be next week, which is predicting the products of a chemical reaction. What compound am I going to get when these two things go together? Okay, I'm going to get this compound here. All right, so magnesium is going to go with iodine. How did I know to write the magnesium first? It's the metal, right? Metals always get written first. Okay, since that's an ionic compound, then I have to remember to do this. Okay, and so we've got a 2 plus and a 1 minus, so I'm going to drop and swap. 1 will go there. Okay, so now I've got the compound, so my products are predicted. That's going to be my product. And now I have to check and see if my reaction is balanced. And it is. Is that very hard? Okay. All you have to do is know the reaction patterns. If you know what happens in each of the 5 types of chemical reactions, it's actually pretty easy to predict what the products of that reaction are going to be. All right, so let's try this one. What kind of reaction am I looking at there? Single replacement. I have an element reacting with an ionic compound. All right. In a single replacement reaction, what happens? Right. They switch? I cut you off, sorry.
That's all. I don't know. They switch elements.
Okay, they switch elements. So this element here that's by itself has to replace some part of this ionic compound. Since chlorine is a non-metal, what part of the compound is it going to replace? The fluorine. All right, it's got to replace the part that it's like. Okay, so it's going to switch places with fluorine. That means fluorine is going to end up by itself, and sodium will now end up with chlorine. All right, so I figured out who goes with who, but I messed something up. What did I forget to do? Okay. I didn't show it, but this is a +1 and this is a -1, so that's. So I did drop and swap it.
You forgot the 2 at the end, yeah.
Right. This is a special element. I have to make sure I write a 2 there. This is where the color coding on your periodic table becomes really important. Always be kind of checking when you're predicting the products of a reaction. If you get a non-metal by itself, check it. Make sure that it's not a special one, or if it is a special one, that it gets the right number. Okay, so now I have correctly predicted my products. What do I need to do? Balance it. Okay, so I'll start with chlorine because it's the biggest number. Okay, there's 2 of them over here. I'll go over here and put a 2 there. That gives me 2 sodiums. So back up, get 2 sodiums, 2 fluorine, 2 fluorine. Looks like I'm okay there. All right. With that. Okay. Is this is this a whole lot different than what we did yesterday? No. I mean, yesterday, yeah, you were given the products, but it's not hard to figure out what they are, thanks to Dalton, who said you're never going to make new elements in a reaction. You're just going to have what you had on the other side. It's just going to switch around. Okay? Separated, joined, or rearranged. All we're doing is separating, joining, or rearranging in the right pattern. Okay, try this one. What kind of reaction are we looking at here?
Combustion.
It's a combustion reaction, right? We got carbon and hydrogen and oxygen as our reactants. What are always the products of a combustion reaction? Carbon dioxide and water. So this isn't one where you have to think about what the products are. This is one where you have to memorize what the products are. Because it doesn't matter how many carbons and hydrogens there are, those are the products. All that changes is how much of those there are going to be. All right, I've correctly predicted my products. Now what do? Now I balance. Do I need both rules for this one? Yes, 2 is an even number. So start with a 2. 2 times 2 is 4. So I'm going to put a 4 over here. 2 times 6 is 12. 6 times 2 is 12 hydrogens. And now I can look at my oxygens. 4 times 2 is 8. So I've got 8 oxygens in the carbon dioxide, plus another 6 in the water, for a total of 14. 7 times 2 is 14. Yes. Okay, is this making sense? Right. Like I said, it's not a whole lot different than what we were doing. It just requires you to really know the patterns of the reactions. Is that someone being pushed in a chair? Why? Okay, what kind of reaction are we looking at here? Simple decomposition, right? This is a decomposition reaction. It's the only kind that has only one reactant, right? There can't be any joining or rearranging in this reaction because there's nothing to join or rearrange. So all this compound can do is break down into its elements. Now, one of the things we have to watch out for with decomposition reactions and single replacement reactions is the formation of special elements, because these are the two reaction types that are likely to cause that to happen. Okay, so we're going to have this breakdown into its elements, S and O, sulfur and oxygen. What do I need to put after the sulfur? Right, sulfur comes as an 8 when it's by itself, and oxygen comes as a 2. All right, so now I got to balance this thing. All right, what should I balance first? Yeah, I'd balance the 8 first. Okay, so we got 8 on this side. Now there's 8 on this side. How many oxygens does that give me? 12, yeah, 4 times 3 is 12. 6 times 2 is 12. And now it's balanced. Okay, so there's little details to always be on the lookout for, and the most common mistake, without exception, when people write reactions is forgetting the special elements. Okay, and it's a simple mistake, but it costs them not only the mark for the reaction, but it costs them the balancing mark as well. Because if I don't write 8 after that sulfur and 2 after that oxygen, I balance that a lot differently. Okay. All right, and let's try this one. Okay, what kind of reaction are we looking at? Double replacement. Okay, now people often look at double replacement reactions and go, okay, that one's gonna be really hard to predict, but it's actually the easiest one, right? All you have to do to predict the products of a double replacement reaction is swap the metals, okay? Just swap the metals and you'll have your new products, right? So that means beryllium will be with oxygen and sodium will be with phosphorus. Okay, now, what kind of compounds did I just make over there? Ionic or molecular? They're ionic, right? I mean, it's a replacement reaction. All there is in a replacement reaction are ionic compounds. What did I not do to either one of them? I didn't drop and swap either one. Okay, so +1 and -3. So we're going to have Na3P. This is a +2, that's a -2. So that one's good the way it's written. Okay, now I got to balance this whole thing. What should I balance first? What should I balance first? Easy. Yeah, I could balance sodium. It's a 3, and our rule is go with the biggest number. Here's what I would say. I would do the beryllium first because beryllium has a bigger charge. Okay? If I've got two numbers that are the same, it's better to balance the one with the bigger charge first because it's going to have more of an impact on the reaction. Okay, so I'm going to start with beryllium. Okay, I mean this might work if I started with sodium, but it's always a good bet to start with the bigger charge. So beryllium's a 3 on this side, so I'm going to go over here and make sure that there's a 3 over here. All right, when I do that, that gives me 3 oxygens. So I need to go over here and make sure that there are 3 oxygens. All right, when I do that, that gives me 6 sodium. So I need to go back over here and make sure that I have 6 sodium, and when I do that, it gives me the right number of phosphorus for the rest of the reaction. Okay, and just looking at it, it would have worked had I done sodium first. Okay, there are just times where it's better to do the bigger charge first. Okay. All right, is that kind of making sense? All right, I'm going to put a couple up here. I'm going to want you to try them yourself without me. Yes. Okay, give those ones a try there, guys. All right, so our first one, what kind of reaction are we looking at on number 6? Single replacement. We got an element reacting with a compound. In this case, the element is a metal. Okay, so the metal is going to replace the metal part of the ionic compound. So that means that lithium will end up by itself, and magnesium will end up with nitrogen. Okay, so things I need to check here. Do I have any special elements by themselves? No, lithium is a metal, there are no special metals. Okay, so it doesn't need a number beside it. Okay, and I have to drop and swap this because it's an ionic compound. This is a -3, this is a +2, so we're going to have 3 and 2 there. And now I need to balance the whole reaction. So again, looking at probably starting with magnesium, I realize lithium is also a 3, but the bigger charge is magnesium. So 3 over there, gonna bring a 3 over here. On that side, there are 2 nitrogens. Okay, so I'm gonna bring a 2 over here, and then I'm gonna have to put a 6 in front of this. Okay, and there's one of the ones where picking the biggest charge matters. If I had started with lithium, I would have had to do it again. Okay, because I would have just brought this 3 over to here, put a 3 here, and then run out.
Does it matter if you did like lithium or if you did like magnesium nitrogen first?
No. No, if you had it written this way, Mg3N2 plus lithium, fine. Yeah, there's no worries on that. The only problem would be if you had nitrogen and then magnesium. Yeah, then it would be a problem. Okay, that's a good question though. Oh, no, I don't want that. Okay, number 7, what kind of reaction are we looking at there? It's a decomposition reaction. All right, so I've got phosphorus or diphosphorus trichloride. That's got to break down into phosphorus and chlorine, both of which are special. In decomposition reactions, we always have to look for that. Phosphorus is very special, chlorine not as much. Okay. Now we've got the right numbers on there. What should I balance first? Phosphorus is the biggest number. Okay, so I'm going to go back over here. Now I've got 4 phosphorus. That gives me 6 chlorines. 3 there takes care of my chlorines. Okay. Everybody good with that? All right. And then for number 8, what kind of reaction are we looking at there? Combustion. Products of combustion reaction are always the same 2 things: carbon dioxide and water. Okay, do I need the rule of 2 on this one? 7 an even number or an odd number? Odd number. Okay, so I don't need it. Okay, so there's 7 carbons, 16 hydrogens, 16 hydrogens. 7 times 2 is 14 oxygens plus 8 more is 22. 11 times 2 is 22. Okay. How are we feeling about those guys? It's not terribly difficult to predict the products of a chemical reaction. You just have to know the patterns. Okay. Now, something else I think we need a little bit of work on is our balancing. Even these ones here didn't require us to think very much in terms of the balancing. They were pretty straightforward. But I do have a couple that I want you to try that are a bit more challenging. Okay, and those would be ones that are closer to the bottom of this worksheet. This worksheet is in your worksheet package, right? But I'll leave it up here, and you guys can get. Some of these are easy. Some of these are like the ones we've been doing, right? But give them a try. See how they go. All right. The key for it was posted yesterday when I posted all the reaction worksheets. All right. Let's have a quick look at R. So R is a double replacement reaction. Right? Everything's an ionic compound in there. What should I balance first? What's the biggest number? Here? Yeah, ammonium, right? NH4 is that polyatomic ion. It's the only one that's positive. It's the only polyatomic ion that behaves like a metal. Okay, so on this side, there are 3 ammoniums on the product side. So I've got to go back over here to the reactant side where there are how many? 1. All right, so I'm going to put a 3 in front of that. But that 3 is also going to apply to the hydroxide. So I've got to go over here to where hydroxide is part of water and make sure that there are 3 of them there. And as soon as I do that, it balances out my hydrogens. There's 3 on this side. And the phosphate is 1 and 1. Right? Now, if you have a fill-in-the-blank balancing, put 1s in blanks. Okay? Because if I'm marking it and I look at it and the blanks aren't filled, I don't know whether you knew it was a 1 or you didn't finish it because you got lost. Okay, so if it's a fill in the blank, put 1s in the blanks. If you're writing out the whole reaction, you don't have to write 1s. Like if you're writing out the whole thing yourself, don't write 1s. I'll know you didn't put them in there for a reason. Okay, but if it's fill in the blank and you leave them blank, it doesn't look done. Okay, and then I don't know which is which. And also, I see this happen sometimes. Should you ever put that in a blank for balancing? No, because that means you don't have any. 0 times anything is? 0. Right, so never write a 0 when you're balancing. Okay, that's it for today. Good work, guys, and have a great week off. Don't do anything I would do. Maybe you should. I don't know. I'm for it.